Yeah, it's recording now. Okay, so project management under risk, simulation as a tool to tackle the risk. So anyway, so let's take one example for example of project evaluation. Evaluation. Okay, let's take an example of. So suppose if you have a project, which needs an initial investment I of $100,000. Okay, and that project is expected to produce an annual benefit of $25,000 annually, and for a foreseeable future of about 8 years. Okay, so having these values in mind, we want to know that whether this project is feasible or not. So we will normally be using the net present value method, or we will want to find the net present value of this project. Okay. So in this case, we will further assume that this project will be evaluated on an interest rate or the discount rate of let me say that k is equal to 12% per year. Okay, 12% per year, and we also expect an inflation of about 3% average over the next 8 years. So if we have this data available, and then we are very sure that all these data will remain constant over the period of 8 years, then this is not the project. Then this is not the condition under the risk. Okay, that is the condition of certainty. So everything is certain in this case. However, in practice, normally this does not happen, and then there are some variabilities in these data. Okay, so for example, the annual benefits, the interest rate may change. There may be a fluctuation in the inflation rate as well. Okay, etc. So let's evaluate under the no risk condition, no risk condition. Okay, no risk condition. Let's evaluate it first under the no risk condition, and then we will evaluate under the risk condition. So in this case, we will find the net present value, NPV. Okay, so the NPV is equal to the present value of the sum of the present value of all the future cash flows. So future cash flows are these $25,000. So for example, if from in the engineering economy terms, if we draw it, there will be an initial investment of $100,000. Okay, I will skip that thousand from here. If the initial investment is $100,000 at 0.0, that means right now, and then at the end of 1 year, second year, third year, and up to, and so on, up to 8th year, each year we are getting back an annual benefit of $25,000. Okay, 25, 25, 25. So this is how the cash flow will look like. So these $25,000 cash flows are in the future. What is their present equivalent? Okay, so engineering economy gives us one formula for the present value when future cash flows are given. So that formula is A is equal to the present value of these future equivalent A values is the present value of these future equivalent A values is, for example, if all these values are represented by A, it is given by this formula. Okay, so 1 plus K, 1 plus the interest rate. So 1 plus the interest rate power n minus 1 divided by the interest rate into 1 plus I power n. Okay, so where I is the total interest rate, which may be the sum of the discount rate and the uh, inflation rate. So we can take I is equal to K plus F, which is equal to 0.15%, 15% actually, which is equal to 15%. So using this formula, then we can calculate the present equivalent of all these 8 values of 25. So in this case, n is the number of years in the future, okay, and I is the 15%, A is 25,000. So therefore, the net present value will be remember that we also have this value, okay, this is in the time 0. So because it is right now, so it will have the same value as we have it, okay, this $100,000, and then plus $25,000 into 1 plus I. 1 plus I is I is 15%, or in decimals, it is 0.15. Okay, so it will be 1 plus 0.5, it will be 1.15 power 8, and then minus 1 divided by 0.15 into 1.15 power 8. So if you will calculate it, then you can get the answer of that. So let's do these calculations conveniently on Microsoft Excel. Okay, so I open one Excel file over here, and I write it over here. I is for the initial investment, and A is the annual benefit. K is the discount rate. Okay, that is the interest rate, which maybe the bank may be charging you or whatever. So it may have several meanings. Okay, F is the inflation rate. I is the sum of K and F. N is the number of periods for which we are calculating it, and the net present value. Okay, so in this case, our the values are $1,000. So $1,000. This is the investment, $100,000, and the annual benefits are $25,000, and this was 12%. Okay, 3%, and then the interest rate will be 12 plus 3. It is 15%. N is 8. N is 8. It is not 8%. So I will change it to some value. N is 8. And net present value. So net present value will be equal to the minus the initial value. Okay, remember that I will take this investment as a minus amount over here, because it is a cash outflow. That is something which you are spending. Okay, so something which you are spending, that is a cash outflow. That is the cash going away from you. It will, when this cash is going away from you, that means it will be a negative cash flow. Okay, and then the annual benefits are the cash inflows. So cash inflows are positive. So for this, I will use the positive sign over here. So there is an inbuilt function in Microsoft Excel for this for the present value of the annual benefit cash flow, which is equivalent to the to this formula. Yeah, which is equivalent to this formula. This present value PV is equal to this function, which is equivalent to this formula. So we will use this function, okay? So this asks the first value as the rate. Rate in this case is this 15%, okay? So I will point it out over here and here at the rate. Then it's asked on NPR, number of periods. So number of periods are 8, okay? This one. And then it asks for the PMT, that is the periodic payment amount. Okay, so the periodic payment amount is this one, $25,000. Okay. However, since this is a Microsoft Excel function, its formula has already been set. So this function works in such a way that if you put a positive value over here, that means this $25,000 over here, it will result into a negative value. Okay, but what we want over here is a positive answer over here. So therefore, we will, for this PMT, we will put a negative sign over here so that negative when negative of negative is positive, we will get a positive answer over here outside. So now I will hit enter and then I will get this value. Okay, so I will.
Professor?
Yes, yes.
Pardon me, what was the F? What is the F?
F is the inflation rate. F is the inflation, rate of inflation. Okay, so in this way, then I get this value, $12,183 net present value. Okay, so we can even check it by just directly applying this formula, whether we are getting it or not. So this is for our, so this is the formula, A into 1 plus I power n. So we can check it over here as well. So let me, this is just for checking, okay? Although if we do it several times, so you will be very sure that this will be the answer. So it is A is 25,000 times bracket 1 plus I. So 1 plus I is this, which is the sum of the discount rate plus the inflation rate. And then power n is this minus 1 and then bracket close, then divided by bracket the inflation rate, which is 15%, into 1 plus the inflation rate. Inflation rate, this is, and then power n.
Professor,
And
I
then,
is the rate or F?
Okay.
F is the inflation. F is the inflation rate. I is the sum of the discount rate and the inflation rate. Okay.
Okay, okay.
Yeah. Okay. So in this case, this formula is okay. Maybe we can just take this. I made some mistake over here. So it is 25,000. Okay, multiplied by 1.13 power 8. Okay, minus 1. Okay, and then divided by 0.15. Sorry, 0.15 multiplied by 1.15 power 8. And then this was, well, this was also 1.15. Okay, just for checking. So it is 129,000. No, this was 0.15. And then minus 100,000. So it is 12,183. Okay. So if you will apply the same, the formula over here, same as this, so we'll get the same answer over here. Anyway, so this is actually not my main discussion today, so I should not spend much time over here. So remember that, I think, because you may be, I think you may be very much wondering why, what is this and that. Okay, K is the discount rate. Okay, K is the discount rate, also called as the interest rate. Okay, also called as the minimum attractive rate of return. It has so many different names. Okay, minimum attractive rate of return. Okay, minimum attractive rate of return. So it has so many different names. 3% is the inflation rate. Okay, inflation, that means the amount of the values of the prices of the goods and services, the increase in the prices of the goods and services at some rate. So these are just some assumptions. Okay, inflation rate, etc. And then this is the sum of I and K. This is I is equal to K plus F. So just to include it into the formula. Okay, so we will use this. Anyway, so we have got $12,183. So based on this data, we can say that this performance, this project will perform very well. If, for example, the annual benefits are $25,000, and then this project in the end is giving us a net present value of $12,183, because this net present value is greater than zero, is positive value. So this means that this project results into a rate of return which is greater than our minimum attractive rate of return. Okay, so in this case, given this situation, this is a feasible solution. However, in the risk situation, the things will not be exactly same. Okay, the things will be maybe much different. Okay, so let's now see what is the risk situation over here. So in the risk situation, maybe what can happen is that each year you may not get like annual benefit like $25,000. Okay, so in the risk situation, for example, each year the situation may not be as simple as we have presented. So we can see that each year 1, 2, 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. So let's see what is the situation each year. Okay, and then I use a term NCF. NCF is the net cash flow. Net cash flow. So a net cash flow each year we obtain not $25,000, but maybe some other amount. Okay, so for example, at the beginning we have spent minus $1,000, $100,000, and initial investment is $100,000. Okay, so that is okay. We are not going in. We are assuming that this initial investment is $100,000. For we are pretty much sure about that. Okay, so just for the sake of simplicity, but in the what the annual benefits are, say maybe sometime in the first year is $25,000. Okay, it's $25,000. But maybe in the second year it is say $20,000. Third year maybe $22,000. Okay, in the fourth year it will be maybe $30,000. Okay, it is in the fifth year it is maybe say $24,000, and then $21,000. Okay. Okay. 7th year it is $19,000. 8th year it is say maybe $18,000. Okay. Okay, so it's the situation like this. So $25,000 was our initial guess, but in reality, this may not be the same. So this will be the situation in for the risk. So there may be a risk that the values may fluctuate in this case. So for example, if the values happen like this, so then what will be the net present value? So the net present value in this case can be calculated as NPV. So net present value can be calculated by considering by discounting these all of these individual cash flows by the discount factor. Okay, so in this case, the discount factor DF will be equal to because discount factor will be applied to all of these individual cash flows. So that will be equal to 1 divided by 1 plus I. I in this case is 0.5. Okay. 1 divided by 1 plus I. So which is I is 0.15%, 15%. And power N. N is the year number. Okay. N is the year number over here. So it is discount factor for the initial investment is 1. Discount factor for the at the end of first year it will be 25,000, and then we will get these discount factors. Okay, by this formula. So this is the discount factor. So remember that what is the meaning of the discount factor over here? So in the engineering economy terms, so if we have a future cash flow of F, then that future cash flow of F is related with its present cash flow by this formula. So present cash flow is equal to future cash flow divided by 1 plus I power n. So I have simply applied this formula. So that means I have taken this factor 1 plus I power n, and that is my discount factor. That is my discount factor in this Excel. Okay, 1 plus 1 over 1 plus I power n. And F are the future cash flows in this case. So here you can see that for year 0, the n is 0, and then it is 1 plus 1 plus 1 plus I power n. So discount factor. So then the discounted cash flow will be equal to the discount factor multiplied by the cash flow in that year. So it will be this one. And in this way, then we can get all these discounted cash flows. So the sum of this all of these discounted cash flows, which is $2,518, that will be the $2,518. That will be the net present value. Okay, so this is the one of the long way of calculating the net present value in Excel. A short way for calculating the net present value in Excel is like that. So we can use the NPV formula instead. So for this formula, we will take this first value, which is already negative, and then plus we get NPV. This is the built-in function in Excel. We will need to provide the value of the rate, which is I over here. And then we will need to provide the values. So values are this. Values are this. So, and then I will close these values. So this will be $2,518. So we will get the same answer. Okay, in this case. Okay, so in this case now, previously our answer was $12,183, but now the answer is $2,500 something. So you can see that there is a difference between the actual situation and the real situation, or it may not this may not be the actual situation. Okay, because actual situation we only know when the time has already passed, but we only plan or evaluate the project well ahead of time over in this case. So this will be the no risk situation. This will be the risk situation. Okay, this will be the risk situation. But remember that this is not actually the real risk management. The real risk management does not give you some specific value. So in this case, all of these are our assumed value. Okay, I mean these values, for example, the annual benefit values may not be exactly same. They may be some different values. So in this case, then what we can see is that we may have many combinations, hundreds or thousands of combinations of these 8 different values. Okay, so we may have thousands, okay, thousands or maybe millions, okay, thousands of different possible scenarios. Okay, so thousands of possible different scenarios, and for each scenario, for each scenario, you will get the net present value. So that means if we say that if we take 1,000 different scenarios, so we will have the 1,000 net present values, 1,000, about 1,000 net present values. So what will be the average of these 1,000 net present values, or in how many times out of these 1,000 times the net present value was the negative, and how many times the net present value was positive. So that may be the situation which we can which we can conveniently find with the in simulation. So for this purpose, so we will perform the simulation. Okay, simulation, and the simulation over here means that it is the Monte Carlo simulation. It is a numerical method for producing the results. Okay, so for that, so that simulation may have a number of scenarios as well. So for example, now we will talk about the simulation results. Okay, simulation results. Okay, simulation results. So for those simulation results, we take a simple case actually, okay, only. Although that case will be relatively unlikely, but we take a simple case. So let's take the simulation results now over here, and then I just copy this data. Okay, so for example, I have this data over here, and suppose that this $25,000, which was our initial estimate for the annual benefit, varies in a manner which can be normally distributed. Okay, so what is the normal distribution? So the normal distribution is something like this. So this is our assumption. Okay, we assume the that $25,000 annual benefit varies in what normal distribution. Okay, so for example, what is the normal distribution? So in the normal distribution, you say that if you say like 1,000 samples of this annual benefits, So it may vary like this in a bell-shaped curve. Okay. So with the mean value of say $22,000 and a standard deviation of say $5,000. Okay, so this is another assumption over here. But in this assumption, we are recognizing the variability in this annual benefits. Okay, with some reasonably determined values. Okay, some reasonably determined values. Okay, so let's see that. Suppose maybe what was the um, for example, what was here the average values? The average value over here was something like $22,300. Yeah. So and then there may be some standard deviation as well. Anyway, so let's assume that these values over here are different. Okay, so these values change randomly uh, for a normal distribution with the mean of $22,000 and the standard deviation of let's say what was I assumed $5,000. Okay, so let's take this new situation in mind. So the mean value for the annual benefit is say $22,000. Okay, and the standard deviation for this is $5,000. Okay, so if this is $5,000, so then if we want to distribute it, so we can use it's a normal distribution function over here. So which will be NORM, norm INV. So this is a function for the normal distribution. So norm distribution, okay, and it asks us the value of the probability. Okay, so what is the value of the probability? So this value of the probability is a random number, okay, is a random number which is uniformly distributed between 0 and 1. So it is a decimal number which will be uniformly distributed between 0 and 1. So I can take it as RAND, and then its form is like RAND like this, RAND, and then empty parenthesis. And the mean value is this, okay, and the standard deviation is this. Okay, $5,000, and then I close it. So this will produce a randomly distributed value, 21,369. Okay, and then I will generate it for the all 8 years. For the all 8 years. Okay, so in this case, what I can see over here is that I get another estimate of the net present value, which is $2,518.12. Okay, which is exactly same. Why? Oh no, which is no, it's not exact. Yeah, this I need to copy and paste this formula. Then this value will change. Okay, so this will be here. Yeah, here in this case, I get these values. Okay, so 49,000. Yeah, you see that. These values are, let me. Okay, here you can see that here I am getting actually yeah, no, I input the wrong formula over here. Copy and then paste over here. Okay, so yeah. It is 99,000. Why? This one. Okay, so here I'm getting is minus $99,000.
Professor, can you repeat the last step?
Yeah, I think there's some mistake. Okay, so equal to, okay, this will be minus 100,000, and then this will be present value, and the rate is this 15%, and yeah, and then the number of periods are 8, and then these sorry, this will be NPV value. NPV, the rate is 15%, and then the values are this one. Yep. So it is $8,085 in this case. No, I made a mistake again. Okay. Okay, equal to this value is equal to minus this first value plus the NPV. The rate is 15%, and these values are here. Okay. So it is $6,438 in this case. So, but remember that I think you can see that each time I'm evaluating this, it is changing. So it is $6,438 over here. Next time, for example, I evaluate it, new random values are generated, and then the value of the net present value also changes over here. So for example, now I am getting $596. Again, next time I'm getting minus $17,191. And then next time I get $1,823. So for each change, I get the new net present value. That means in this case, if we somehow, I can capture all these values, and then I can take the mean and average of these values, then we can get some more information about this project. Okay, so up to now, after that, I will now show the simulation program, and then it will further elaborate the results. So do you have any question up to at this point? Do you have any question up to at this point?
Professor, I missed the point. Why this 1823 changed from 66,800 something?
Well, this is $1,823.
Yes, before, like a few seconds ago, it was 6,800.
Yeah, and right now it is also changed to minus 12,000.
Yeah. Mm-hmm.
Because if in this case we are using a random number inside of this normal distribution formula, so that random number changes all the time. Okay, equal. So for example, this is rand, and I will yeah. So right now the random number is 0.4705, and there may be some other random number over here. Here the random number now is 0.37. Here the random number is now 0.44. So that random number will keep on changing. And so the purpose of this random number is to generate the randomly distributed data, okay, which follows some distribution, which in this case is the normal distribution. Okay. So we have used this random number to generate a set of data, but that set of data we want to represent somehow over here. Okay. So that's why we are generating different values over here. 0.208, now it's minus 11,895. Okay, now is minus 11,425. Now is $16,538. So this randomly distributed data we have, we are generating, and then we are assuming that, let's say we have, say, a sample of, say, 1,000 data. Out of that 1,000, how many times the number will be less than 0, how many times the number will be more than 0. And based on that, we can evaluate the problem. Okay. So any more questions about this? Okay, so we can do this switch simulation in one of the several ways. So for example, if I take the data and copy it in the next one over here, the next sheet. So for example, if I copy it over here and I take the now $22,000. Yeah, $22,000 over here, $22,000. And the standard deviation of say $5,000. $5,000. Okay, so this data can be generated like this. So for example, now we can take the trial. Okay, I can take the trial and let's do something like this. So trial, okay, 1, trial 2. And then for the trial, for each trial, I will have the random number, okay, random number, okay, random number. So, and then for each random number, I will have the value of A, okay, and for each value of A, I will have the net present value. Okay, so let's put it like this. So I have the random number RAND, rand, its formula is equal RAND, rand. This will be the random number. And then what will be the value of A? The value of A will be the normally distributed, NORM, 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 INV, okay? Normally distributed. Is this normal distribution function in Microsoft Excel is norm INV. So the probability, I will take this random number. Mean value is I am taking as $22,000, and the standard deviation I'm taking as $5,000. Okay, so this will be the generated value. So okay, this will be the generated value, and the net present value will be equal to, for example, this will be equal to minus 100,000 and plus PV, and then rate was 15%. And in this case, and the number of periods were 8, and this value is given over here. Okay, so this will be the value. So at minus 20,434 minus in this case. So now I have generated these values. So for example, now I can just copy it down, and then so the trials are like this plus 1. Okay, so it's for the trial. The number of trials. So for example, now I take like 1,000 trials over here. Okay, so about 1,000, not many. Okay, so I have taken 1,000 trials, okay? And for each trial, and let's see that I don't want to change these values, okay? So random number. So I take these Control Shift down arrow. I take these values, copy it, and then I will just paste these values, like, so that later on the values will not change. So now I have these non-changing values. So based on this random number generated value, I have now 1000 trial values over here. Okay. I think something happened in my Excel, so that I do it again. So 1000 trials, okay? So I take exactly 1000 trials, and then I have these random numbers. I copy these random numbers and then paste at the same position as the values. Okay, so, and here I have these net present values. Okay, so these are the net present values. So now in this case, some of the net present values are negatives, and some of the net present values are positive over here as well. Okay, so you can see that some positive values, some negative values over here based on this data. So what is the distribution of this net present values? So for this, I need to say that Control Shift, and then I will select it. And then from here, we can see that from the negative net present values, I can see that the average is minus $1,243, and total 1,000 values I have obtained. Minimum is this. Minimum is minus $79,000, maximum is $81,000. And how these values are distributed, for this we can even plot these values. Okay, we can plot these values, and then we can see the distribution. But I will not do the plotting over here. I want to show you this simulation program over here. So for this simulation program, which is the called the model risk, so we need to set up the sheet first. Okay, so I will set up this sheet. So I will use the same data end of year. Okay, and then 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we evaluate this project for the next 8 years. And then the cash flows are minus $100,000. Minus $100,000, and then these are like $22,000. Okay. And based on this, we can find the net present value, okay, which is equal to minus 100,000 plus the net present value. The interest rate we are using is 15%, so it will be 0.15, or you can enter as 15%, or you can also enter at 0.15, so both will be the same. And the values are here, and then close it. So yeah, just checking it. So the values are from B3 to B10, yeah, minus 1,278.93. So for the simulation, okay, over here, I will just copy and paste this data. Okay, I will just copy and paste this data over here. And now for the simulation, I have this add-in which is called as the model risk. So you can download this add-in and then you can install it on your, it will install on in your Microsoft Excel program, and it will appear over here as over here. If you don't see it over here and then you have installed it, then what you can see is you can go to this file menu, options, and add-ins. You will click add-in, and under this over here, it will be there in the list. So it will be there in the Excel add-in, and then you can click go. And over here, you will have was functions. It will be under this name, was functions. Okay. And then you can install it. VOSC, was is the company which is making this add-in, and then you can use it. So once you have this model risk as installed over here, you have to, there are of course several things over here and which you can do. There are several things which you can do over here, but mainly we need to do a few things over here. So first thing is the select the distribution. Okay, we have to select the distribution. So in this case, we will click the select distribution and then select distribution. And then here you will see that you will see a chart for the number of different types of distributions. In this case, you will go to the common one. Okay, common one. The full version of this program provides you more than 100 different types of distributions. So when you install this program for the first time, it will give you like 15 days for to try this program with full functionality. But since I have installed this program some time ago, my program is now not a full version. It is only a basic version. So in the basic version, you can only try only a few of the distributions. So some of these distributions which have been shown as star over here, it is only available in the full version. Okay. So no, the one, yeah, it is only, these are only available in the full versions. But anyway, we are not using so many different types of distributions. The distribution which we want to use, which is the normal distribution, we still can use in this program in the basic version. So you will go to the common and then you will select the normal. Okay. And then you will click OK. So in the normal distribution, the program will now ask you to provide the mu and sigma values. So mu is for the mean value. Okay, it can also mean the mode and median as well, but in here we are taking the mean value. So we want to take the mean value. So the mean value we want to take is 22,000. Okay, so one thing I think we need to do is I need to cancel it. I need to cancel it over here and then need to select this column first, because here I want to apply the distribution. Okay, I want to change these values of the annual benefits. So I will first select it and then I will select the distribution. Select the distribution. I will go to the common, and in the common, because in this case my focus is to use the normal distribution. So I will select the normal distribution over here and then I will click OK. In the normal distribution, now it is asking me to provide the value for the normal distribution, which is $22,000. Okay, which is $22,000. So I will select this cell. And then next, it is asking me to provide the cell for the standard deviation. So you can provide the cell for the standard deviation. I did not put any standard deviation cell over here. So you can simply type the standard deviation as $5,000 over here. Okay. So if you provide it in a cell, so you can point it towards the cell as well. So After doing this, we just need to provide these two inputs, and then you will click this button over here, insert to worksheet. So this has now been inserted in the worksheet, and then you can see that the formula for this has already been changed. So this formula is a special formula which is used by this model risk program. So we can now copy and paste this formula for the other remaining 7 years as well. Okay, so for the remaining 7 years as well. So it is now giving us like 7,022 each time. So which may be causing a mistake. Okay, so I think what I can do is I know why it's happening like that, because it is just taking the first value and then copying it into the second value. I want these values to vary each time. So what I can do is I can take the mean and then the standard deviation over here. So mean is $22,000 and the standard deviation is $5,000. Okay, and now I apply this distribution again. Select. So the mu is now this, and the sigma is now this. Okay, and now insert to the worksheet, and now I will apply this. So again, there is some mistake over here. Okay, so because the references, I did not fix those references. So the references are changing. Okay, so for this, I need to go back again, select the distribution, and then I selected this distribution, and then I clicked OK, and then I selected the sigma, and then I clicked OK over here, and then I inserted it to the worksheet. Now, if I don't want the references to change, so then I will need to click into this formula. So for example, over here, I need to click into this formula, and then I need to press F4 button to make them as the non-changing references. So I will press F4. So these will be the non-changing references. Okay. So it will be now this, and I will apply it again. So now it seems to be working. Okay. So now it seems to be working. Okay. So in this case, now what I have got is a value of $8,962 based on these shown values. Okay. So this is for the net present value. Net present value forecasted. Net present value forecasted. So, and then you can see that each time it is changing it as well. Okay, but here the real benefit of this software comes. So now after you have selected this distribution, the next step is to select the output value. Okay, so the output, our output is, we have to mark the output first. So I have to mark the output first. Our output is in this cell. So I will select this cell as the output. And then there's an optional output for the name of the output. So that is the net present value forecasted. So it will be net present value forecasted, and this is the output. Okay, this we have to identify, and then I will click OK. So with these two steps, with these two very basic steps, the model has been completed, and now we can run the simulation. So for running the simulations, we first need to select the sample. So by default, 1,000 samples have been shown. I have been shown over here. You can change it to any value which you like. Okay, so I don't want to change it too much. So maybe more sample you will take, you will get more smooth answers. Okay, and it will also take some more time for the simulation as well. But anyway, for 1,000 samples, it will take not much time. Okay, just a few seconds. So 1000 samples have been taken, which means that this value of the net present value will be calculated 1000 times, and then its distribution will be shown to you in front of you. Okay, so you will click start, and then on this right hand side simulation will be taking place, and then it will give you this, the program will give you these results. Okay, so it will show you a histogram for the plot. It will show you a histogram for the plot, and then some data and statistics on the right hand side. Okay, so let's see this histogram first. So this histogram shows you the distribution of the net present values. Remember that our output function was this. So this was our output function. Okay, so this program will produce the results into our output function, which is the net present value. Okay, so the program has plotted the net present value against the number of time it was occurred in the range. So for example, from the range of 2000 to 3000, from the range of 3000 to 4000. So how many times it has occurred. Okay, so in this case, what we can see is, so this is the distribution. So first of all, we can look at some of the statistics over here. So the statistics, most common statistics which we are concerned over here is this, the mean value, which is shown as $1,932 is the mean value. So mean value is positive in this case, so which shows that this project has a good potential. Okay, that means out of 1000 times, that means if we plot it 1000 times, so for those 1000 net present values, the mean value is a positive value. Okay, can you see it from here, where my mouse pointer is? Can you see it from
Yes.
here?
Yes.
Yeah,
Yes.
1900. So it is a positive value. And the minimum value is minus $30,000. The maximum value is $39,000. So this is for our indication only. However, but the problem area comes from this standard deviation as well, $12,387. So standard deviation is much more than the mean value over here, which means that although the mean value is positive, but there is a greater chance that this mean value can become a negative value by this very great standard deviation. So for example, if the standard deviation means that it can move towards the positive side as well, and it can move towards the negative side as well. Okay, so there is a greater chance that the positive value can become a negative value as well. And how many, what is the chance for this project to go into a negative net present value? So that we can approximate from these percentile values over here as well. So for example, at 1%, it is 25,132, which means that there's a 1% chance that the value or net present value of the project will be less than $25,000. So it is a negative value. There is a 5% chance that the value will be less than $19,000. There is a 15% chance the value will be less than minus $11,000. So up to now over here, yeah. So between 35 and 45%, the value changes from negative to positive. Okay, minus 3,000 to plus $386 over here. Okay, so this means that there is almost like 40% chance that the project will have a negative cash flow value. So this we can also see from here in this histogram. Okay, so if you move this this vertical pointer left and right, so you can see the values are changing over here. So this at this point now it shows 7.49%, and the net present value is negative $16,000. So if I move it towards right, so the negative value will be minus 12,325, and then it is now minus $7,136. And if I move it something like here, so it is at about 44%, and it is minus $32. So it is almost equal to zero. So zero value is over here, shown over here. Okay, zero value is shown over here. So it means that there is a 44% chance in this project. There is a 44% chance in this project that the net present value will be negative. Okay, 44% chance of this project. So in this case, if I say write it like over here is that in this project, yeah, in the simulated scenario, the mean value was, what was the mean value? Mean values was 1932, okay? Mean value was 1932, okay? And the standard deviation was what? 12,387. 12,387. And the percent times, okay, percent times negative net present value, that is about 45%, okay? That is about 44.25%, okay? 44.25%. So that is about 44%. So based on this, will you say that this is a good project or not? That means there is a 44% chance for the project will go into the loss. And then the standard deviation is also much more greater than the project. So then it will say that, you will see that the risk in the project is too high. Risk in the financial success of project is high. So which means that it is too risky to invest in this project. So you may most likely may not be investing in this project in this case. So this will be the conclusion. Do you have any question about this?
Professor?
Yes.
At what percentage then it would have been fine project to invest in?
Yeah. So for a low risk project, okay, for a low risk project, the mean value, the standard deviation must be less than the mean value, okay, and then at least this percentage time the net present value should be also much lower as well. Okay.
Much lower is like 10% or 30% or less than 10?
Yes.
How much?
No, yeah, there is no relative figure. The 10-20% is okay. It's quite fine. It also depends on the how much you want to take the risk. Okay, it depends on the risk tolerance for the company as well. Okay.
Mm-hmm.
Yeah. Okay. So there is one thing I think in this case is that over here. I have produced these results, but since now my project, this model risk program has become a basic version, so I can only I can only save a limited set of reports as well. So for example, if you want to save the results, so what you have to do is you have to take the screenshot of these statistics from here. Okay. And then you can plot it over here. At this point, you can only plot this, you can only save this histogram over here. So this, in this program, if you go to this home button and then the report, and then in the report, actually, many of these things are only available in the full version as well. But in this case, you can plot the full report with the statistics as well. So in this case, what you can select is these, create the report in a Microsoft Excel as a new workbook or in the current workbook. Okay, maybe you can do it in the current workbook and then you can create the report. So it will, the report has been generated. So when the report is generated, so you can go back to this workbook and you will see that this workbook will be generated over here. Only the summary will be provided, but the detailed statistics, for the detailed statistics, I think these statistics, maybe you can just you can just take the screenshot. So for example, you can snap those. So for example, new, and then here you can just place it in your spreadsheet. So this one, and then you can do the for the next one as well. And then when you save this report over here, so it will, the next one will be the spreadsheet view over here. So this is the spreadsheet view. This will be also saved in your spreadsheet. Okay, so that was something about the model risk. You can also see the data as well, insert, and then statistics. So you can see, you can also see the statistics from here as well. Okay, but it's not, the program is not allowing you to copy it over here. But when you will, because if in the, it is only available in the completed version. So, and then you can even save it. So you can save it for your future use. Okay, so simulation 1. Okay, let's see, it will be saved, and then you can recall it later on. Or you can try it also with the more number of samples as well. So if you will click it, you can save that. If you want to save the current simulation results for the workbook, okay, you can say that. Okay, simulation 1. Okay, save. And now it is, now I'm doing it with 5,000 points, 5,000 samples. So it will take a little bit time. So you will get a similar results. So here the what you can see is the standard deviation is 12,000. So similar answers, okay, and the mean values have slightly decreased as well. So the more number of simulations, the more defined the answer that you will get it. Okay. Oh, we have run out of time, and so that's all for today. So do you have any questions?
No.
Okay, so that's all. Then let's see you on the next lesson on Thursday.
Thank you, Professor Bali.
Goodbye, Professor.
Thank you. Bye-bye.
Thank you. Goodbye.